はい、もうちょっと待ってください。はい、大丈夫です。じゃあ、始めちゃいます。So, good morning and good afternoon, everyone. Thank you for joining this today's, online seminar between Eteku municipalities and Umegeni Water, Young Water Professional on South African side, and Yokohama Water Works Bureau from Japan side. So, my name is Yusuke Takagi from Yokohama Water Works Bureau. I will be today's MC. So, and I will just very briefly explain about today's timetable. Yeah, this is today's timetable. And actually today we have about 25 panelists participating on Zoom. And in addition to that, this seminar is broadcasted on YouTube live streaming. So many observers are watching it. And today we have participants from Eteku municipality, Umegeni Water, and a young water professional from South African side. So this is today's timetable. After having an opening and introduction, we will have overview presentation from both Eteku Water and Water Sanitation Unit and Umegeni Water. And after that, we have an overview presentation from Yokohama Water Works Bureau. In the following part, we will divide it into two teams, two discussion rooms. And we will have our thematic knowledge exchange, which means a discussion. And here on YouTube, only discussion B, water distribution management and supply services, will be live streamed on YouTube. So please enjoy it. And after having a discussion in two separated teams, we will come back to the main room and we will have a reporting session here. Some of our panelist members will report what we have learned in the previous, discussion. And after that, we will have a closing session. So now I'd like to move to the actual contents. So first of all, I'd like to invite Ms. Lungi, Eteku municipality, to deliver opening remarks from South African side. So please, Ms. Lungi.
Thank you very much, Mr. Takagi. Good day, everyone, and thank you for attending this knowledge exchange seminar between young water professionals from Durban in South Africa and Yokohama in Japan. From the South African side, we are joined by young water professionals from Eteku Water and Sanitation, which is the water services provider in Eteku municipality. We have young water professionals from Umegeni Water, which is the bulk water supplier within the province of KwaZulu-Natal. And we have young water professionals from the Water Institute of Southern Africa, WISA. So these three organizations, I believe, cover a sizable portion of the young water professionals working in the water sector in our city and in our province of KwaZulu-Natal. So from the South African side, I believe that we are well represented. I'm hopeful and certain that the seminar will go well and both parties will learn from each other, and this will contribute to the improvement of the work that we do for our citizens and our residents in our prospective cities. Let this newly formed relationship not end here, and let us carry on engaging in a smaller group, on a smaller group basis based on our different work areas. So colleagues, with this short introduction, I wish us fruitful discussions for the rest of the seminar. Thank you very much.
Thank you very much, Ms. Lungi. Now I'd like to invite Ms. Rie Kamori from Yokohama Water Works side to deliver opening remarks. So Ms. Kamori, please.
Thank you, Mr. Takagi. And good morning and good afternoon, ladies and gentlemen. I am Rie Kanmori, Manager of International Operations Division, Yokohama Waterworks Bureau. On behalf of Yokohama, it is my great pleasure to give opening remarks for this important online event. Yokohama is the city where Japan's first modern water supply was founded in 1887. Taking advantage of the experience over 130 years, Yokohama Waterworks Bureau has been making international contributions by sending our staff to foreign countries and accepting trainees from abroad, including South Africa, for more than 40 years since 1973. I heard that the SADGA JWWA joint seminars for water supply sector were successfully implemented already 2 times in the last 2 months, and the 3rd seminar will be held in next week. I believe that these seminars have promoted knowledge exchanges and will enhance the organizational capabilities for water utilities of South Africa as well as Japan. Today, young water professionals of both countries are gathered here and will discuss their challenges and roles. I think your opinions and foresights toward the coming future are very important and valuable for our water sector. I hope that all participants are encouraged to contribute for active discussion today. Finally, I would like to convey my sincere thanks to all relevant organizations, eteku wini Water and Sanitation Unit, Ungeni Water, Young Water Professionals South Africa, Water Institute of Southern Africa, South African Local Government Association, Japan International Cooperation Agency, Japan Waterworks Association, Yachio Engineering Company Limited, and my Yokohama Waterworks Bureau, whose staff's continuous effort make this seminar possible. Thank you very much.
Okay, thank you very much, Ms. Kanmori. Actually, today we have many panelists, so the introduction of each panelist will be done in discussion session. Now I'd like to move on to the overview presentation from South African side first. So I'd like to invite Mr. Desmond to deliver an overview presentation from South Africa. So Mr. Desmond, please share your screen and start presentation.
Excuse me, Mr. Takagi. We will start with Mr. Njabulo first with the presentation.
Oh, okay. Sorry for that. So Mr. Njabulo, please share your screen and start it.
All right, just sorting out the technology here. It should come up shortly. Please confirm if you can see the contents of my screen. Can you see the contents of my screen, please?
Yes, I can see your screen. Yeah, please start.
Okay, thank you very much. Firstly, good morning and good afternoon to our colleagues in South Africa and Japan, respectively. Mine is a very short presentation, which is to introduce to the members of the panel and our audience at large the organization that I'm part of, Ungeni Water. So my presentation has 3 sections. Firstly, I will present the outline of Ungeni Water, which is the organization in numbers itself, and then present quickly its operational area, the area in which we function as an organization. And then lastly, I'll present the supply system that provides the city of eThekwini with water. So that is going to be the core of my presentation. So ladies and gentlemen, Umgeni Water in numbers. This is a fairly young organization in relation to Yokohama Waterworks Bureau. We are an organ of state established in 1974, sorry. That makes us just under 50 years old. As an organization in the past year, which is 2020, we abstracted over 500 million cubic meters of water from a system of abstraction networks and dams, which we own and operate. This was to provide water to our customers through our water treatment works infrastructure. So we provided in the past year over 540 million cubic meters of potable water to our customers. So in total, we have about 7 customers. And because we are a bulk provider, we abstract from dams, treat in bulk, and then convey or distribute water in bulk to our various sales points with our customers, with the city of eThekwini being one of them. So with our infrastructure network, we operate a network of over 1,260 pipelines. We have drilled through mountains several times, so we've got about 67 kilometers total length of tunnels. And I use the word approximately because as I speak to you, our infrastructure build program continues. We are building more pipelines, so this number grows on a continual basis. On our side of the production network, we've consistently managed to maintain our losses, to keep our losses below 5%. I think maybe ours may be slightly easier when one compares to the city of eThekwini with multiple connections that may even run in the thousands, if not millions. So ours is relatively easier to maintain our losses to be below 5% of the volume of water that we supply. Organizationally, no, we are not that big as yet. We employ just over 1,010 people, and interestingly enough, of our total population, 40% of these are under the age of 35. So, which makes us a fairly young, dynamic organization, and it's always interesting when one also is given opportunities to participate in knowledge sharing exercises at this age. So we're a fairly young organization age-wise. As I did say, we supply at least 7 municipal customers at this moment in time. And the population that we supply is closer to 9 million. And take into account that eThekwini, or the city of Durban, is the most populous city in the province. So I think the numbers are around half of this. So there should be around 3.7, 3.8 million. I'm not too sure. But this means that eThekwini, the city of eThekwini, is Umgeni Water's biggest customers in simple terms. And as an organization, we are working progressively, obviously, to supply the entire province of KwaZulu-Natal. Just to put the matters into perspective graphically, this is the map of KwaZulu-Natal. The shade in amber is our current customer base. These are our current customers. We are growing as an organization. The shade in green is a customer that we've acquired recently. But what I just wanted to stress out is that the entire province of KwaZulu-Natal is home to about 11 million people, and 70% of that population are found in this tiny corridor of the cities of Durban and Pietermaritzburg. And this is where the backbone of Umgeni Water's bulk infrastructure resides. So it's by no fluke that eThekwini is our biggest customer. That's where the most of the population in the province is situated. So in simple terms, I would like to then just present the supply overview of eThekwini. This is just a snapshot of the bulk water system that supplies the towns of Pietermaritzburg and eThekwini as the most populous towns in the province. But my focus for this presentation is obviously eThekwini, which is Durban. So we supply the city of Durban using a series of dams, about 6 dams of varying sizes, with interbasin transfers at the top of the catchment. So our newest dam that we have up top, Spring Grove, which is about 140 million cubic meters in terms of total storage, is used to then pump water into our main river catchment where we exist, the Umgeni River catchment. This is where the oldest dams in the province are found, and those are the dams that I think they were built around the 60s and 70s, some of them, and with recent upgrades as early as the late 90s for the case of Midma. So these are the dams that supply the city of eThekwini, and we have a series of pipelines, pumps, water treatment works that provide drinking water to the 2 major towns in the area. So our biggest water treatment works is found in Durban. So I think it treats about 614 or 620 million liters of water a day, supplying the town of the city of Durban and surrounding areas. So through this system, we have been able to supply, just over this past year, we have been able to supply the city of Durban with at least 416 million cubic meters of water just this past year. And that constituted at least 70% of the volume that we as Umgeni Water treated and sold to our customers. So as I did say, the city of Durban is our largest customer. So obviously from how we then manage the water from this point forward becomes important to both of us. It's not just a matter of the city providing water to people and us happily selling at the fence. If there are high water losses on the side of eThekwini, it also affects us as Umgeni Water. Yes, we may say in the short term we make more money by selling water, but in the long run, the whole water service delivery system will collapse if we don't work together as entities that provide basic services to people. So that's the long and short of my introduction of Umgeni Water to this knowledge sharing seminar. And in the interest of time, I will stop there and hand back control to the host of the conference. I thank you.
Okay, thank you very much, Mr. Jabro. Probably next, we will have a presentation from eThekwini municipality.
Good morning, and thank you for the introduction from Umgeni Water as well. I'm sorry for joining late. I've been having connectivity issues, and I'm hoping that my presentation will be in line with our counterparts from Umgeni Water. I will try and share my screen, which is a presentation I put together. Just give me a second. Can you please confirm if you can see my screen?
Yes, I can see your screen.
Okay, thank you so much. I missed the introduction earlier on. So just to introduce myself, my name is Desmond Tabati. I'm representing eThekwini municipality from the bulk water infrastructure side of things. I am a professional technologist by profession. I'll just briefly go through what we've put together as eThekwini municipality, and it's mostly information that we put together from one of our consultants who was doing a study for us. So as you could, okay, so I'll just move on to my first. All right. In this presentation, I'll try and cover a bit of introduction and background, which I've noticed our counterpart from Umgeni Water has covered some of it. So we'll cover the coverage as a metropolitan unicity, and then we'll look at a few issues around demographics and town planning. We'll also touch on our existing water sources, water treatment works, pump stations, and reservoirs. And we'll talk briefly on trunk mains and whatever the issues that we are faced with. But in the interest of time, let's just move on to the next slide. So again, as might have highlighted by Umgeni Water, EWS is a water services authority, and obviously we need to comply with the requirements of the WSA. We are a metropolitan municipality within the KwaZulu-Natal province with diverse cultures, demographics, and town planning schemes. From the I think 2 slides before Jabulo ended his presentation, he showed a larger overview of the KwaZulu-Natal province. We constitute about 2.5 square kilometers within the KwaZulu-Natal province. And within Tokeni municipality, we are subdivided into 5 regions, which is the north, the central, inner west, outer west, south, and the south. Demographically, we are a big metropolitan city. I do not want to go too much into the details of within this slide, which I believe we're going to be sharing these slides after this, so you guys can peruse that as we go. There are a few developments that earmarked within the municipality, some being private developments and some being managed by or introduced by the government as human settlement developments, which then puts a strain on the current supplies and storage capacities of the current setup of the municipality. Some just an example of a few developments that are already earmarked in the municipality, and there's a whole lot of them which we would then need to provide supply of water to. Sorry, is someone trying to say something?
I don't think so. So you can continue.
Okay. All right. Thank you for that. A couple of consultants are obviously looking at all the demands and requirements in terms of water supply for the various projects. In terms of growth and within the municipality, the historical growth has been about 1.3%. As you can see, the stats we collected from Stats Africa. And it's all there for your perusal at the end of the presentation. We have seen a huge growth in terms of demand, as I mentioned earlier on, and the average supply at the moment, we are sitting at 17 megaliters per day. And Umgeni Water, I don't know if that figure is still correct. Jabulo can intervene, and I'm not sure what, because I missed part of his presentation. He would have covered that. Again, this was covered by Umgeni Water. Our supply comes from the Umgeni system, and there is a planned supply from the south coast and the north coast, as outlined in the Umgeni Water presentation earlier on. That also was covered in Jabulo's presentation, where he spoke about the Mians Weir and Spring Grove Dam that he mentioned earlier. We have a few water treatment works within the municipality, and they are all outlined in here with the operational capacities that we currently have and spare capacities. And obviously, due to space constraints, there are a few alternatives that the municipality is looking at in terms of increasing the capacities and, of course, new treatment works that may be required. These are Umgeni Water owned and operated treatment works, and I would assume that Jabulo would have covered that part in his presentation. eThekwini municipality is fed by about 350 storage reservoirs and a vast number of pump stations within the municipality to push water to our consumers. The existing reservoirs capacity are generally adequate, although some of them are still lacking in terms of providing 48 storage for consumers during, as you may know, load shedding periods, and of course, if there are major bursts and leaks that we need to attend to. The pipe network within the municipality, as you may be aware, we get water from Umgeni Water at strategic points, which get distributed to various reservoirs within the municipality. We have approximately 1,000 kilometers length of bulk trunk mains, which I am responsible for. And then beyond the reservoirs, our network operations colleagues take over with that reticulation into the consumers and so forth. I will not get into details with the current sizes that we've got, which is probably not so important at the moment, but we deal with trunk mains ranging from as little as 100 diameters all the way to 1.4 diameter steel pipelines. There are new projects that have been launched, which is the Western Aqueduct, Western Aqueduct and the Northern Aqueduct, which is meant to feed the top northernmost parts of the municipality. And on the reticulation side, there are various housing projects done by the EWS design units and handed over to operations. You have private developments, as I mentioned earlier on, who also require supply. The water demands currently, and this is based on a couple of years back, averaging about 897 megaliters per day, and that may have changed by now. And I'm pretty sure Jabulo would have covered that in his presentation. Based on the three growth scenarios, the 25-year projected demand therefore requires that EWS would need to upgrade or construct new storage to meet the demands that are required. There are a few supply scenarios that have been looked at, which is getting water supply systems that would feed the Umgeni water, eThekwini municipality, in order to meet the requirements over the next 25 years. That includes some schemes down in the north and the south coast of the municipality, and of course from the Umgeni water system. There are also options that have been looked at, which is looking at the reuse of the water, being the clean water or wastewater resources that we can tap into. So that would mean looking into the various wastewater treatment works and seeing solutions out of that. These are just a few wastewater treatment works that have been looked at as possibilities for water reuse. And that's just a few more of those. So as you can see, there are a couple of wastewater treatment works that we could be using for such a solution. The current challenges we experience as eThekwini municipality is the SCADA system and the telemetry infrastructure, which we would go a long way in making sure that we do not have any outages or extended water losses within our systems. Of course, cathodic protection is one of the other issues that we are having challenges with. The current system or protection that we've got is either vandalized or is not operational. So that obviously affects the lifespan of our pipelines. Aging infrastructure, which is a serious issue as well. Some of the pipes were laid in the 60s, 70s. So pipe relay programs are obviously some of the options that needs to be looked at in order for us to reduce our non-revenue water amount. I think due to the time limitations and all that, we've tried to summarize as best as we can. And I would like to thank you all for the opportunity, and obviously thank our consultant for putting together the information for us. Yeah, again, thank you.
Thank you very much for your presentation, Mr. Desmond. Before moving on to the next presentation, I'd like to clarify one thing, especially for Japanese observers. So I think for Japanese observers, the city of Durban is still a bit familiar, but actually city of Durban changed its name to eThekwini municipality. So which means that the eThekwini municipality is the same with actually it's same with the previous, city of Durban. So I just wanted to confirm this part. And then I'd like to invite Mr. Mitsuru Shiraishi to deliver overview presentation from Yokohama Waterworks site. Mitsuru, please.
So, excuse me, can you hear my voice? Is it okay? Okay. So, I'm gonna start my presentation. Good morning, everyone. Sanibonani. I'm Mr. Shiraishi from Yokohama Waterworks Bureau, YWWB. Please call me Michael. It's my nickname. Talking about South Africa, Springboks is one of my favorite national rugby team, and I really want to congratulate your victory in 2019 World Cup held in Japan. As you know, the final match was held in Yokohama. It is quite pity that our national team Brave Blossoms defeated by the Springboks. But I really want to make good relations, so only today I forget about the game, only today. From now, I would like to explain about the outline of water supply in Yokohama. First, I would like to talk about the location. Yokohama is located almost in the center of the islands of Japan. The 4 seasons are clear. In summer, it's hot and humid, and in winter, it's cold and dry. Rainy seasons starts in June and ends in July. This is our organization chart. Area of this big blue square is the city government's organization. Mayor is the top. There are 27 bureaus in the city government, and Yokohama Waterworks Bureau, YWWB, is one of them. The Director General is like a CEO of YWWB, and Yokohama Waterworks Bureau has like these many departments inside a bureau. We have almost 1,500 staff, and most of them are employed by the city and posted to the bureau. Next, I'd like to talk about financial matter. As you know, governmental services, such like establishing a road or establishing public facilities, are funded by taxpayers. But on the other hand, in Yokohama, costs related to the waterworks operations are funded by water charges paid by customers. The finance is independent from the city government, so it's easy to capture the balance of costs and revenue. We call this self-supporting accounting system. This slide shows a basic information of Yokohama Waterworks Bureau. Our service started in 1887. This is the earliest modern water supply service in our country. We have the longest history in all water utilities in Japan. Almost 130 years have passed. We have more than 1,890,000 water connections. Ratio of non-revenue water is about 7.4%. And leakage ratio is 5%. And the bill collecting ratio is 99.5%. This graph shows the transition of daily supply volume. Population is still gradually increasing in Yokohama. However, water supply volume is declining. We experienced severe water shortage in 1990s, particularly in 1995. We had suffered from severe dry summer. We campaigned saving water to citizens. Since then, water supply volume shows downward tendency because of citizens' consciousness to save water and also effect of water saving technology. This tendency affects our revenue, and now our management circumstance becomes severe. This is the water supply system of Yokohama Waterworks Bureau. We have 3 water treatment plants, WTPs, here, and also here. Hawaii, Nishia, and Kosuzume water purification plants. With 3 water sources, it has a total capacity of 1.7 million cubic meter per day. All water sources are outside of the city. For example, in Doshi River system, this yellow line, we carry water as far as 44 kilometers. In 1969, Kanagawa Prefecture and Kawasaki City and Yokosuka City, and we, Yokohama City, established the Kanagawa Water Supply Authority as a bulk water supplier. We call this KWSA. This authority purifies raw water taken from two rivers, Sagami River and Sakawa River, and supply it to 4 member bodies of KWSA. In Japan, water supply is responsibility of local government. However, nowadays, it is promoted to supply water by wider area, integrating several water utilities under towns or cities. The purpose is to prevent overlapping investment to waterworks facilities and their efficient placement and management. Elevation of the systems of YWWB. These 5 lines show the water's path from intakes to water treatment plants, WTPs. From the viewpoint of altitude, the height, these red and yellow lines are gravity flow systems. You can see these 2 lines are waters are coming from higher places to lower places. Other 3 systems, green and pink and purple line, are using pumping systems to take water from downstream of river. These are established after the period of high economic growth and used much energy to operate. In conclusion, for eco-friendly system, we are prioritizing these 2 gravity flow systems in facility development. From now, I would like to talk about water distribution. In order to ensure the proper pressure throughout the city, we introduced water distribution block system. We have 22 distribution reservoirs, and according to the arrangement of them, we divide the city into 25 blocks. In general, each block has 1 distribution reservoir, 1 pump station, and we divide the area into two blocks, like one is a pumping area and another is gravity flow area. Yokohama has a rugged and complex terrain. In addition, during the period of high economic growth, a lot of pumps were installed unplanned. These situations made water pressure control difficult. So we have adopted this system since 1971. The distribution system in Yokohama will be explained by Mr. Matsubara later in Water Distribution Management and Water Supply Services section. By the way, non-revenue water is a major challenge in many countries. This table is the result of water balance analysis of Yokohama based on IWA method, International Water Association method. In Yokohama, the non-revenue water ratio is 7.4%. As a breakdown, there are almost no illegal connections. This is due to the fact that the water supply coverage has reached 100%. And we have proper customer management and water reading accuracies. Mr. Urata will explain about these things in the next section. Now, I'm going to tell you about the history of leakage control in YWWB. As a countermeasure against non-revenue water, a leakage management section was set up in 1948. Since then, we have reduced water leakage to around 5 to 6%, while introducing various technologies like these. We also started pipe replacement activities since 1970 to prevent water leakage and countermeasure for disasters. We are replacing distribution pipeline about 110 kilometers per year. Next, I'll introduce two systems for managing water supply. First, SCADA, supervisory control and data acquisition. This is a system we use to totally manage water supply. We need to grasp various data of current water supply situations, such as water volume, pressure, and quality. For that purpose, SCADA system is installed in Yokohama, which networks intake facility, WTP, water purification plants, and distribution reservoirs, and water measurement equipment in distribution network. Secondly, I briefly introduce our mapping system, aka GIS, the Geographic Information System. It is a data storage system of every kind of information of pipeline facilities, such as locations, the pipe size, the pipe material that we are using, and installed year, depth, and so on. The information of pipelines in here. Then, based on the developed mapping system data, 1/500th scale paper pipeline maps like this picture are created and distributed to each operation and management office, OM office. Office staff use these maps for their day-to-day operation. And whenever there is a change, staff modify the maps by handwriting. Then, quarterly, the modified maps are submitted to this GIS section for updating. So we can say that these maps shows the latest information of pipelines. These activities are strongly linked to stable water supply services and proper customer management. So far, I talked about technical aspects. From now, I will explain mainly administrative issues. This table shows our current water tariff. Our tariff has two structures, basic rate and metered rate. And the metered rates differ according to the category of usage: domestic use of daily living, business use, and public bathing facilities. The charge is metered and collected every 2 months. Now, this slide shows the image of a progressive water rate system in Yokohama City. Our water supply prime cost, I mean the production cost per 1 cubic meter of water, is about 170 yen. This includes both operating and capital costs. The system reduces cost of water for daily use, like here, you can see it from here, and collects the shortage from a large consumers. As you can recognize from this, it is effective to calculate the prime cost of the water supply in order to determine an appropriate water rate or to promote tariff revision. But this water tariff was set about 20 years ago. Until now, lots of things have changed. Not only people's lifestyle, but also water usage situation. So recently, we're planning to revise our water tariff to suit to our current circumstances. This is the end of my presentation about outline of waterworks in Yokohama. Thank you very much for your kind attention. Siabonga.
Well, thank you very much, Mr. Michael. Thank you for your presentation. So now we'd like to divide our team into two teams and to have a discussion And on YouTube, as I said before, the discussion B, a discussion about the water distribution management and water supply services will be live streamed. So and we have a 15 minutes discussion, and we'll come back to the main room. Ms. Suzuki-san, are you ready to divide the team?
Yes, I already prepared.
Okay, please do so if you got ready.
Good morning for South Africa and good afternoon for Japanese. This is Hitoshi Tsuruga speaking. I'm facilitator for Class B, Water Distribution Management and Water Supply Service. And Mr. Matsubara, young engineer, will make a presentation for 15 minutes and followed by question and answer and exchange opinion session. So we will start off with giving a presentation. Mr. Matsubara, please make a presentation.
Hi, hello, my name is Ken Matsubara, 27 years old. So I will start sharing my picture. Can you see the presentation slide? I will start. So I'm in charge of, I'm in charge of Northern Water Distribution Management Division. So today I'd like to talk about water distribution management. So this is today's contents in 15 minutes. So first, I'd like to reconfirm what the water distribution is. So as you know, after purification plant, water passed through treated water transmission facility and stored in distribution reservoir and pumping station, and then distributed to each household through distribution pipe network and service pipes. We shouldn't forget that the primary aim of the water distribution is to maintain safety by preventing contamination and deterioration until water is delivered to customers. So then, what should we think about? Essential factors of water supply are quantity and pressure and quality or maybe disinfection. And Water Supply Service Act in Japan stipulates the requirement for each factor at the point of tapping. First is quantity and pressure, and about quality and disinfection too. In Japan has 51 drinking water quality standard items. This is composed of 2 biological standards and 33 chemical and 5 physical items and 11 disinfection byproducts. And sampling points should be at water tap in principle. The relationship between water quality standards items and water distribution management is quite complicated. Stable water supply, pressure control and disinfection, stagnant water prevention, and water flow control and the integrity of them are indispensable. Today, I will explain some essential parts of how YWWB manage and control the water situation inside the pipeline. One important thing is to grasp the current water flow situation. We are monitoring the status of water flow on real time by using SCADA system. And especially for water distribution management, we think the important thing is quantity, pressure, and turbidity, and chlorination, and color in the pipes. By taking these data, we can not only grasp the current water flow, but we can also notice the change and take care as speedy as possible. And moreover, we use these data for more accurate analysis. Then I will introduce how we control and analyze. One important thing is water pressure. This picture shows easy concept of water pressure, this left hand. And when the reservoir water level is, for example, 49 meters and the ground level is 9 meters, we roughly understand the water pressure is about 40 meters, which is 0.39 megapascal. And this, the right-hand picture is the elevation map of Yokohama City. And red color area shows the place where ground level is high, and blue color area is where the ground level is low. In Japan, water pressure should be higher than 0.15 megapascal and not exceed 0.74 megapascal at the point of tapping. But Yokohama City consists of complicated rolling hills, so YWWB had a lot of difficulty in managing the pressure. So YWWB adopted distribution block systems in 1971 to regulate the pressure. YWWB divided Yokohama City into 25 blocks, and each block is an independent water supply area. Vertical boundary of block is determined by elevation also. And the horizontal size is determined by the scale of reservoirs mainly. So even now, we sometimes change the boundary. The main merits of the distribution block system are mentioned below. The main points are the accuracy of the management and the ease of recovery. Rather than looking at the whole Yokohama City, it is easier to understand the water supply situation and easy to regulate. Even if an accident happens, it would be easy to identify the location and the influence would be limited inside these boundaries. Block system is also useful to control the volume. Distribution reservoir has the function of storing the treated water and adjusting the amount of water supply. Yokohama City has 22 reservoirs. This picture shows Nogeyama Reservoir with capacity of 40,000 cubic meters. And this is the average scale reservoir in Yokohama City. And this supply water to about 170,000 customers. As I showed in the recent slide, blue area, which ground level is high, are supplied by pump, and green area, which is near seaside area, are supplied by gravity. To manage water more accurately, we also care about the amount and the change in the days. This graph shows the change of water demand in some day in Miho pumping area. For example, in the midnight, as many people sleep, water demand is very low, but after people wakes up, they go to bathroom or maybe cook breakfast, go to toilet. So the demand will increase at this level. And this pattern depends on a situation of region or area. Area which has many office streets, the pattern will be different. And by grasping this tendency, you can distribute the water certainly and efficiently. To characterize the area, we set a coefficient named hourly factor. And hourly factor can be calculated by dividing the maximum volume by average volume. For example, we can decide how much amount we should keep in the reservoir. Or it is useful to predict the maximum volume inside the pipelines, which is important for hydraulic analysis. Block system also let us reduce the damage in case some accident happens in nearby area. This is an example of backup by water interchange. This is zoom up of part of Yokohama, and Buko pumping area is an area between Nishiya area and Imai pumping area. If Buko pumping station stopped by an accident, Nishiya pumping station and Imai pumping station will shoulder the north part of Buko area and the southern part of Buko area, respectively. But it's not so easy because there will be a big change about volumes and pressure also. We prepare backup plans for each 25 blocks so that we can supply water continuously even in case of accidents. Let's take a closer look. This is the map of distribution pipeline, and red line shows distribution pipes. In Yokohama, there are 9,300 kilometers of distribution pipe all over the Yokohama city. Generally, it is difficult to understand the water flow inside these kind of bridge type pipeline. But in YWWB, we graph the amount, velocity, and direction of water flowing inside the pipelines by hydraulic analysis. This is the result of hydraulic analysis. Top value shows the diameter of pipe, and middle figure shows quantity, and bottom one shows the velocity. And this arrow sign shows the direction. And each node also has the information about pressure and water demands. We consider the methods to keep the essential factors in best condition. After these analysis and planning, if we want to change the water situation, we shut or open the valve and change the water flow in distribution management. These are some examples of how we prevent the stagnant water. The best way to replace stagnant water with fresh one is to carry out by periodic rain. Stagnant water results from both little demand and pipe ends. Looping is another way. Stagnant water is sometimes caused by inappropriate shut valve, which makes just one-way flow. In this case, it is best to transform water flow from one-way to circle-way. This is called looping. Or conversely, transform water from looping to one-way, depending on the situation. The longer time it takes water to reach customers, the older water becomes. So third way, third way is to change the position of boundary and balance between these different blocks. Water flow control is also helpful to keep disinfection effect. This is the distribution map of residual chlorine concentration. We check 643 fixed measurement points in the summer. As a result of distribution blocking system and the stagnant water prevention, almost all measured values fall within the target range, as you can see in this map. These were about the essential factors: pressure and volume and quality and disinfection. There are still more things to control, for example, turbidity. But sorry, I won't go into details today. I'm pleased if you realize how important and how complicated and how difficult the water distribution management is. And water distribution management contributes to safe and stable water supply and definitely leads to improvement of public health and living environment. Thank you for your attention.
Thank you very much, Mr. Matsubara. Short presentation, but high density presentation. So, do you have any question or opinion from South Africa? Or do you have the slide you want to run again?
Yes, I do have a question for Mr. Matsubara.
Yes.
Thank you so much. Thank you so much for your presentation, Mr. Matsubara. I just wanted to find out, in terms of the water quality management, what is it that you actually do? Do you do any management programs from the water treatment works? And what are they, and how do you ensure that that complies with your national standards?
Mm. とりあえずさ、とりあえずこれはあれだから排水処理、排水管理の話だからさ、とりあえずあれかな。スライド2とかで説明した方がいいかもしれない。
Sorry, actually, in my distribution, it is almost automatically controlled in upper flow.
Wait a moment.
Yes, she tried to go in.
So, in the area of distribution management, we don't control the upper flow. So, different distribution, different workers will control about the dams or reservoir, and we just control the pipeline, the water flow inside the pipeline. But actually in Yokohama, we also control by SCADA systems or different planning, not by hydraulic analysis actually. Is this?
水質管理をどうしてるかっていう。
sorry. So, and about quality, it is also controlled by some different distributions, and we actually control mainly about the slide number 6, quantity, pressure, and about about the water quality, we mainly control all the turbidity and chlorination. Yes.
Yes, your question is how do we keep the quality of water? Yes, of course, the water quality as the outlet of water treatment plant will secure the Japanese national standard. But in water distribution system, it is important to keep water quality by keep water pressure stably and prevent stagnant water. Yes, slide 3. Yes, please. Yes, second point. The prime aim of water distribution management is to maintain safety by preventing contamination and deterioration until water is delivered to customers. This is the factor of water distribution management to keep quality.
Is it okay, Bari-san?
Yes, thank you.
Zabasawa-san? Mr. Zabasawa? Miss. Sorry. Sorry, Miss.
Miss. Konnichiwa. Good morning, colleagues from Japan, colleagues from South Africa, Mgeni Water, Salga, and all the represented organizations. I actually have 3 questions, so I don't know if I should ask one at a time or leave the rest for later. I can go ahead.
Sorry?
Yes, you can.
Okay. The first question is about the billing. In one of the presentations, you mentioned that you bill 92% of your customers. So I'd like to know who is this 8% who is not billed, and why are they not being billed, just for information purposes.
Revenue water? You mean revenue water ratio?
Yes, you said it's 92% of the customers that you are billing at the moment. So I'm trying to figure out the remaining 8%. Who is it? Is it like your free basic water? What constitutes of the 8% that is not being billed?
8% はなんで徴収されてないの？
Could you wait a moment?
Okay.
You may just a moment. You mentioned this slide. This one.
Yes.
これもっと違うページなかったっけ？
Yeah, this one. That's not this one. This one is better, I think. Okay. This one is not billed water. This one is revenue water. So actually, system input volume minus non-revenue water ratio is this one. So this one is a revenue water, not billed one, not billed amount. And billed amount for billed amount. Just a moment. Yes, this one. 99.5% customer pay. This is a situation.
Okay.
You understand? Are you clear? This is the answer. Okay.
All right. Thank you. That question is answered. I'm sorted. Question number 2. I want to ask if the hydraulic model that you showed, is it a live model, like from a real-time data, or is it just a model that you use to using your collected data? Is it from a real-time? Is it a real-time model that you showed us earlier on for the city of Yokohama?
Sorry, please give
The
me.
hydraulic model.
Yes.
Yes, what I want to know that, is it a live model where you getting real-time data from your meters, feeding information into your hydraulic model, or is it a manual one?
どのように水量をこのモデルの中の水量っていうのはどのようにか入手しているの？
Actually, it is not accurately real time, but in once in 3 months or maybe one year, we renew the model. So yeah, yes, it from the mapping system, the different system, not scatter.
Oh, okay. All right, so is it for the whole city of Yokohama, or is just a portion of the city?
We can do both because we divide in the block system. So we can take data from each block, so maybe it will take time, but we can do it by whole area in Yokohama too.
Oh, I thought that you have a whole model of the city, because it's one of the things that we were interested in looking at as the city of Durban. We also have like little models for various zones, but I thought you guys already have the entire city's hydraulic model.
It takes quite a lot of time to analyze because the data is very big if we do it by whole city. So to do it efficiently, the block system is better.
Oh, okay, thank you. And the last question, do you have any rural areas in Yokohama?
郊外のエリアってありますか？
Or rural areas that you're supplying water to?
Yes.
Oh, so are you billing those people? Do you bill them? Do you collect revenue from those people in the rural areas as well?
Yes, we don't have, actually, we don't have rural area.
Oh, okay.
Yes, we only have urbanized area only.
Oh, okay. All right, thank you.
Thank you very much. And Miss Livonier, please.
Thank you so much. Yeah, thanks for the really impressive presentation. I had a question around, it's sort of linked to the last one, but it's around population growth and urbanization. The SCADA system looks so impressive, but how do you account for when you need to upgrade the system? What is the process like in terms of coordinating physical upgrades of pipes and upgrading the SCADA system? And is there a way for consumers to report any issues on the ground, or do you rely quite highly on the SCADA system for picking up any issues with pipelines or reservoirs and that sort of thing? And then lastly, what is your general turnaround time for operation and maintenance? I just saw your non-revenue water is really low, so I'm assuming your O&M section is really impressive. So those are my 3 questions. Thank you.
我々の課題感について聞いてるのかなということです。
整備の話。
どう決めか特に拡大する。
そう、人の歴史の話を聞けますね。
歴史
問題がなかったな。
歴史の話してた。
Yeah. Okay. When we expanded the water supply system, before the construction work, always we forecast the water demand, and along with the water demand forecasting, we develop the facilities. So actually, in our history, we have no gaps between water demand and facility development. Yes, this is the situation. Yes, this is our situation, I think. So how is your situation? Now you tap the water. I don't know the situation in your city or your country. How do you think in your situation?
Yeah, I think with us, there's quite a shift between rural to urban migration. So sometimes we do have a gap in terms of the projected demand versus what actually happens on the ground. So the gap between that is what we're trying to close now. And with increased urbanization, there is quite a demand on the system that wasn't predicted for maybe say 5 years back, 10 years back. So that's currently what we're trying to manage as well.
Thank you very much. Okay, next one is non-revenue water. You are interested in.
Yeah, just in terms of the operation and maintenance turnaround, I thought it was really smart to have the link between the O&M section and GIS. And I'm just wondering, in Ken's network, what is the turnaround time for a report that operation and maintenance is needed and when it's actually done? So I'm just curious about that.
Okay. For non-revenue water reduction, one thing is one component is commercial loss. But in Yokohama situation, maybe another session members are discussing, I think. We can manage the customer properly. So we have almost no commercial losses. This is one of the reasons our non-revenue water is very small. And also for technical side, most efficient way is the pipe replacement, I think. We are replacing the pipe 110 kilometers per year. So this is very good effect, I think. And also we established the leakage survey teams and plan the survey we conducting. This is also another aspect, I think. Is it okay? Okay.
And Mr. Desmond? Mr. Desmond?
Thank you so much. Thanks for the opportunity. I'm interested in your cathodic protection. That is one of the issues that we are struggling with at the moment. What is your status of your cathodic protection, and is it linked to your SCADA and GIS, and how do you manage that in Yokohama?
Cathodic protection?
Correct.
You try to install cathodic protection. You try to install cathodic protection.
We do have existing cathodic protection, but obviously the maintenance of it was not looked at or taken as actively as it should have. On the new lines, we do install cathodic protection, but obviously we need to learn going forward as to how best to sort of maintain the cathodic protection to elongate the lifespan of our pipelines.
Actually, it is not with the SCADA system. It is different. We don't control the cathodic things by data.
Yeah, I'm sorry, we have cathodic protection, some cathodic protection, but sorry, I don't have the data now, but I don't have any program for cathodic protection. We don't have a problem.
What the reason of the cathodic situation in South Africa?
Sorry, what?
Soil issue or some generating facilities? I don't know. What is the main reason of your issues, cathodic?
It's obviously the issue of corrosion, and some of our trunk mains and pipelines do cross railway lines, streams, and etc. So that comes in handy in prolonging the lifespan. So I would have assumed that since you guys are also more urbanized, you would have. I mean, you've got lots and lots of trains. I'd assume, and obviously the pipe would get affected by that, and you would require some cathodic protection. I see you've spoken about relays. Obviously, that comes at a cost, whereas you would rather want to prolong what you've got and then look at relays as a last resort.
Yes, our almost pipeline is ductile cast iron pipe. Yeah, so we don't need to cathodic protection because electricity doesn't pass the pipeline because ductile iron pipe is isolated.
All right. Yeah, maybe that's where my first question should have been. Are you using mostly ductile or just normal steel as we do? Okay, that's fine. In coming from the maintenance side of things here in eThekwini municipality, is in terms of your ground teams. Do you have lots of ground teams that attend to jobs quicker? I'm linking this to what Rivonia asked earlier. Your turnaround time seems to be very short. Is it because you've got lots of ground teams, or let's say in terms of vehicles to attend to these issues, your bursts and leaks?
Yes, we have quite a lot of teams, and also the blocking system is helpful because we can quickly cut off the leakage. Maybe.
Sorry. So you're saying
sorry.
You can quickly cut off the leakage. So you're doing it remotely.
No.
Okay, on the ground as well. Okay. All right. Thank you.
Thank you very much. We have 10 minutes. Do you have any question? Miss Wabisa, please.
Good morning, good afternoon. Thank you for the opportunity. I just have two questions. Just on the technology that you guys use for leak detection, and possibly also the technology, the real-time monitoring that you mentioned of the quality of the water. So to check the turbidity and the chlorination. Can you basically just explain what type of technology that you have? Because you're also doing some research at Umgeni Water on real-time monitoring sensors. So we'd like to get maybe briefly what technology that you guys use.
Leakage detection. You mentioned leakage detection. You want to know?
Yes, one is leak detection and the real-time monitoring of the quality of the water.
Yeah, for leakage detection, we established a dedicated team for leakage detection, and also we use a lot of equipment like acoustic rod, and also leakage detector. But how to say? Just a moment. Yes. This is our histories. So first, we make leakage survey block maps. We prepare, and one by one, we survey the areas, and for 3 years interval, we check whole cities. This is our way, and we introduce a lot of technologies. But it's how to say? It depends on the pipe insulation situation and pipe material. In Yokohama, we adapt the ductile iron pipe for distribution pipe. So actually easy to detect the leakage. But for PVC or HDPE, the leakage sound is very small. You cannot, very difficult. I understand the situation. But actually, we combine a lot of technologies and identify the leakage point. So yes, this is the situation. Okay. What do you want to know? Is it okay?
Right. Thank you.
Thank you.
Yes, yes. Thank you.
Can I put something? By using SCADA system and keep the water pressure high. When the water pressure goes down very quickly, that means the leakage happens. So that's one thing how we can detect the leakage.
Yes.
And, yes. And by putting many points, many attachments in the pipelines to keep data to SCADA system, we can also grasp not pinpoint, but where the we can detect the place by area. Then we can cut off the area, or maybe using backups, we can keep the water supply and after cutting off some area, we can detect where the leakage happens after cutting off. So that's how we reduce the non-revenue water when leakage happens. No, all point.
All right, thank you.
Okay.
And the censoring of the quality of the water, or like the turbidity and the chlorination, what type of technology do you use for that?
Sorry, what type of
do you use sensors, and what type of sensors do you use to get the real-time data for the turbidity and the chlorination?
What type of sensor do we have?
Do you guys use sensors to get the information, or what type of other technology do you use to get the information? Or is it?
まあ、さっきのスライドとりあえず見せて、スキャダのスライド見せて。
Each point are all the sensor, yes, as you say.
Yes, we have a many type of the sensors for turbidity, or for water quality, for water pressure, and for water volume. So yes, this is the situation. So you can see the different color. Yes.
That's all right. Thank you.
Thank you.
Thank you. 1 minute, Mr. Desmond. This is the last question.
Okay, I'll try to be quick. In terms of your SCADA, your control room, is this also a broad overview of Yokohama city, or do you have separate control rooms for each portion that you've distributed the bigger city into? Thanks.
We can see wide area version, and also each blocks. But actually, it is different. It's different monitor. We have to change the monitor, but the same system.
Is it okay?
Okay. Okay. Miss Sandeka. Miss Sandeka, please.
Hi, thank you for the presentation. I'm just interested, I see you guys are way ahead of technology. Most of your stuff is automated. I'm just interested in your water works. Do you have people manning the process, your process controllers? If so, how many do you normally have?
Do you want to know the number of staff?
Okay. This one. This one, 1,500 staff we have, and we have 1, 2, 3, 4, 5, 6, 7, 8 department. Okay.
And so per waterworks, so normally how many people do you have in one waterworks?
In one water distribution management section, water distribution department, yes, 272 people staff we have. Okay.
Okay, Takagi-san, お返しします。
Hi, so coming. Okay, thank you for coming back to the main rooms. Now I'd like to have a reporting session, but because of time constraint, so let's hear what we have done very briefly. I'd like to start from my side. I joined the Group A, Water Bill Collection and Customer Management. I think I have learned 3 things from South African side. The first one is legal connection is very huge problem in South Africa, and they are talking about it is important to consider how to protect meters. Because in Japan, this is not a huge problem, but I think because we are working on the JICA project, probably we need to think about how to, protect meters. It's the first thing. And secondly, it was very interesting that Eteku Wini municipality have their own internal staff members to do meter reading. But in addition to that, they outsource meter reading to subcontractors. I think they have combined system. This was interesting to me. And the final one is about Ms. Lungi mentioned that water is human rights in South Africa. This is very interesting to me. I mean, they offer free water to people in poverty, but there is debate that cost money should be compensated from city government, from the revenue from taxation or not. I think in Japan we had a similar discussion on the COVID-19. If we should compensate the water payment of the people, I mean the deduction of payment from taxation money, or Water Works Bureau should pay for that. I think this kind of debate is a bit similar. I have run these 3 things. And next, I'd like to invite Ms. Lima Castro from our team to share what they have run on South African side, please. Sorry, probably my pronunciation was bad. So Miss Lima Castro, or
Miss Lima.
Yes. Yeah.
Sorry for my pronunciation, but it's bad. Sorry for that.
Good day. Could you please just repeat yourself for me once more?
Oh, I'd like to, I want you to report what you have learned in the discussion A. Just raise some, important points.
Okay. Okay, so thank you for the opportunity. We had some very good discussions in the breakaway room A. A lot of the discussions were around metering, how to protect metering, but also considerations around the use of smart metering and how feasible this would be for the South African context rather. I know we spoke a lot in comparison to Yokohama, and we did establish that there definitely is a difference in cultural backgrounds that ultimately impacts how both these municipalities would then operate, and also the challenges that they each face. They are unique, as you have mentioned. But also another topic that we went on to cover was the issue around informal settlements and the challenge around billing those type of customers. In Japan, you don't have a lot of these informal settlements, but I think for the municipality, or eThekwini municipality rather, that's probably one of their biggest challenges in terms of billing these informal settlements. And also the system that Japan or Yokohama is using, you said it's called Aquastaff. It seems to rely a lot on just the customer themselves being open and honest and providing this information also, which helps with its excellent operation. But I think more for the municipality side, I think they've picked up quite a lot regarding the collection system, but also how to think of solutions around their metering and improving their bill collections. For the water board side, since I'm from Umgeni Water, I think one of the challenge that perhaps we would share with the municipalities is more around metering, protecting our meters from vandalism, etc. But yes, it has been an informative session, and thank you.
Okay, thank you very much. And I'd like to move on to the discussion B, water distribution management. So from discussion B, Mr. Segawa-san, please report what you have learned in the session.
Okay, thank you very much. For group B, I feel 50 minutes are very short for discussion, but first, Yokohama Water Works Bureau provided the information. What is the water distribution management? It means to control the water volume, water pressure, and water quality. And for the purpose of it, Yokohama Water Works Bureau introduced water distribution management blocks, water distribution block system. So after that, we receive a lot of questions from South African members. But in my feeling, a lot of participants from South Africa are interested in non-revenue water reduction. So yes, I think our discussing topic should be non-revenue water reduction. But yes, in our session, we discussed how to detect a leakage or how to reduce the non-revenue water, these kind of things. Actually, we were discussing. Okay, that's all. Thank you very much.
Okay, thank you very much, Mr. Segawa. Now I'd like to invite Ms. Babisa to report the contents of discussion, please.
Thank you. We had a great session, a breakaway session. basically what we had questions about. The ETEGwini people basically asked about the billing and well, non-revenue water, and how if Yokohama has rural areas, because now a great problem that we have in South Africa is how to bill the people in the rural areas. So the Yokohama people basically said that they don't have rural areas and don't have problems with that. And then we also discussed a bit about cathodic protection. And we had a question basically on cathodic protection. And what we found is that the materials that are used in Yokohama don't require that much cathodic protection. So basically, maybe we should also look into the materials that we use and adjust that accordingly. Another thing that we also discussed was the leak detection and the monitoring of leaks, which is something that greatly impacts Ngeni water and ETEGwini municipality. Most of the water is lost through leaks. They basically took us through the leak detection process and the surveys that Yokohama does, and that was pretty informative. Thank you.
Okay, thank you very much. Next, from Young Water Professional, Ms. Tandeka-san, please share your thoughts.
Okay, I was also in breakaway room B, where we were discussing water distribution management. And so the essence and crux of it was how to distribute safe and stable water just to improve human health. Not to also take away from what my colleague has just shared, but in addition, we discussed where there were questions around how does Japan handle a growth in population in terms of linking their upgrade systems, in terms of their SCADA and distribution. So, and as well as their turnaround time for maintenance, because most of their systems are largely automated. So they said that they do a lot of forecasting. So there's a lot of planning. So they prided themselves in saying that there's no gaps between property development and the actual water demand. So they are really able to forecast the demands of the water, as well as the fact that their GIS systems and their programs always ensure that there is almost no water loss. And they also use customer profiling. So that is something else that assists them in terms of forecasting and their operations and management. The interesting thing again for me, which I will touch on, is the fact that there are no rural areas, because ETEGwini highlighted the billing issue, and Yokohama doesn't seem to have that challenge as compared to ETEGwini. So that is something that was interesting. Even in fact of the block system that they are using, they said there are models that they are using. However, it doesn't really look at the entire city. However, it just looks at the certain blocks, because it uses large amounts of data. So in order for it to work efficiently, they streamline it using this block system to actually get an actual model that is able to serve the purpose. And they do this every 3 months. So yeah, that is mostly what we had discussed.
Okay, thank you very much. It seems like we had a very fruitful discussion in both teams. So thank you very much for sharing your thoughts, reporters. Next, I'd like to move on to the final session, closing. I'd like to invite Mr. Jabro to deliver closing remarks from South African side, please.
Thank you, Mr. Takaki-san. Thank you very much. Thank you to the colleagues from Japan. Thank you to the colleagues from South Africa. It was indeed a fruitful discussion, and we trust that this is not really the end of these knowledge sharing sessions, because we can learn a lot from each other. And I believe that within this collective, actually, there is potential to make the needle move forward in terms of improving water service delivery and quality of life in our respective cities and countries. So we thank you for the time. We thank you for the opportunity. We learned a lot in terms of organizing the event itself. There are things we did well, there are things we could have done better, but I believe a start, the fact that we made a start outweighs all the potential glitches. Thanks to JICA, thanks Salga, thanks Eteku Wini Water and Sanitation, thanks WISA, thanks thanks Umgeni Water. We really appreciate this, especially between JICA and Salga. We are looking forward to having you as the foundation of this relationship going forward. Let there be many more exchanges of this kind. And with that said, thank you, colleagues. I will say to be continued. I can't say farewell because, yeah, the journey continues from here. Thank you.
Okay, thank you very much, Jabro. Next, I'd like to invite Mr. Hitoshi Tsuruga, the leader of WITA, to deliver closing remarks, please.
Thank you, Takagi-san. Let me show some slides. Yes. 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 In Japan, almost 100% of people can get water from water supply system on premises. This is because distribution pipe network was laid all around the places people are living. On the other, 1/3 of population, or 2.2 billion people around the world, lack safe drinking water. SDGs aim to achieve universal and equitable access to safe and affordable drinking water for all by 2030. The water supply system is called equipment industry because capital expenditure accounts for the majority of total expenditure. This means that the cost for water supply business does not vary so much depending on the amount of water supply. The left graph shows the asset for pipe accounts for 75% of total assets in Yokohama water supply system. The right table shows that over 60% of capex is used for replacement of old pipes. Therefore, key factors to succeed water supply business are both how well we can manage water distribution system and how well we can collect water bill. Therefore, I think today's themes are very good. I hope that South African side could find something from this seminar, and you are eager to try it. But this is my message. Don't just imitate our activities and practice that make better, especially if you make mistakes. This is my message for South African side and Japanese side. So Yokohama Water Works Bureau should not hesitate to share our experience and knowledge. Also, we can learn a lot of things from South African side. Thank you very much for opportunity. Thank you very much for your cooperation.
Thank you very much, Mr. Tsuruga, for very striking closing remarks. We are very proud of having you in the team. So finally, this seminar is supported by many people. In particular, this seminar among youngsters in water sectors in both South Africa and Japan. This was very much supported by Mr. William from Salga. So we do appreciate it. And finally, we'd like to ask Mr. William to deliver final closing remarks, please.
No, thanks for the opportunity. I won't be long noting the time. Good evening to the Japanese colleagues and morning to our local colleagues. Just a couple of points. In the first instance, we encourage that the idea that was born out of a discussion I had with Miyoshi and Osawa-san has bore fruits. So we're quite excited that you took the challenge and you make it happen that the two cities in particular supported by Mgeni, including the YWP of WISA, put their brains together to make sure that this seminar happens. So thank you so very much for that. And importantly, from our side, Salga, the president of the country has challenged us to look at building a capable state. So from our side, we'll be using the youth to attain that particular objective. And secondly, that through engagements with your good selves, we should be able to emerge victorious in terms of some of the objectives we've set ourselves. So lastly, there are a lot of takeaways that emerged out of the discussions. And Lungi, we wish to challenge you to reflect on the session with your colleagues and begin to look at a way of how we can forge the partnerships with Yokohama, because I think it's a journey that is starting today, and we look forward to further discussions in the improvement of water management. Let me leave it at that. And maybe finally that, let me acknowledge JICA, Mr. Osawa. Your ongoing support is much appreciated, including JWWA in absentia. And equally important that the secretariat behind the scenes, Miyoshi and Risa, thank you so very much for all your support. And yeah, let me leave it at that. Thank you so much.
Okay, thank you very much your comments, Mr. William. This is the end of the session. So thank you very much. I believe our online seminar contributed to strengthening our partnership. So thank you very much, everyone. And see you in the future. Thank you.
Thank you. Bye.
Bye.
Thank you very much, everybody.
Thank you very much.
Thank you. Bye.
Bye.